Hello everyone, this is Afzalur Rahman. In our today's class, we are going to discuss about two topics. One is isoelectric point and another one is peptides and its classification. Actually, in our last class, I forgot to discuss these two topics. So I have decided to take these topics in our today's class. Okay. So first of all, we will discuss about isoelectric point. Okay. So isoelectric point. दिस टॉपिक आइसोइलेक्ट्रिक पॉइंट, ये टॉपिक समझने के पहले आप लोगों को और एक दूसरा टॉपिक का कॉन्सेप्ट होना जरूरी है, जो हम लोगों ने लेक्चर 8 में ऑलरेडी डिस्कस कर चुके हैं. द नेम ऑफ दिस टॉपिक इज ज़्विटर आयन. ओके ना, वी ऑलरेडी नो व्हाट इज ज़्विटर आयन. व्हाट इज ज़्विटर आयन? We know this amino acid in aqueous solution, they exist as a dipolar ion, and this dipolar ion is called Zwitter ion. Okay, that we have already discussed in our previous lecture. Okay, in lecture 8. Okay, so suppose this is one Zwitter ion, R bond CH bond NH3 plus bond COO minus. Okay. So we know this is an amino acid. This is an amino acid, okay, and this amino acid in aqueous solution, it exists as a dipolar ion. Dipolar ion. Okay, in a same molecule there will be two charge. One is positive charge and another one is negative charge. Okay, and such type of ion is called Zwitter ion or dipolar ion. Okay. So this is Zwitter ion. Zwitter ion. Okay. Now we are, with the help of this, the concept of Zwitter ion, we are going to discuss about isoelectric point. Okay. Now you see this Zwitter ion, this dipolar ion, in presence of an acidic solution. In presence of an acidic solution. Okay. Suppose in presence of acidic solution. Okay, what will happen? This dipolar ion is no longer it will not exist as dipolar ion in presence of acidic solution. In presence of acidic solution, acidic solution की presence में ये dipolar ion और Zwitter ion, okay, इस डाइपोलर फॉर्म में नहीं रहेगा. ओके, इट विल कन्वर्ट टू सम अदर फॉर्म. ओके, सो इन एसिडिक सॉल्यूशन, वी नो इन एसिडिक सॉल्यूशन देयर इज एक्सटेंसिव और देयर इज लार्ज नंबर ऑफ प्रोटॉन्स. देयर इज लार्ज नंबर ऑफ प्रोटॉन्स और H+. ओके, सो दिस डाइपोलर आयन इन प्रेजेंस ऑफ एसिडिक सॉल्यूशन, it will pick up a proton from this acidic solution. Okay, so this COO minus will pick up a proton from this acidic solution and it will become COH. It will become COH. Okay, so what will be the structure? You see the structure: NH3 plus bond CH bond R bond COH. Okay, here you see in acidic solution this is no longer a dipolar ion. This is no longer a dipolar ion. Okay, here it is a cation. Here it is a cation. Here you see we have positive charge. Okay, so it exists as cationic form. Okay, suppose this is the structure number 1, structure 1, and this is structure 2. Okay, so this exists as cation. In acidic solution. Okay, and in presence of basic solution, in presence of basic medium. Okay, basic medium means in presence of base. That is, suppose in presence of NaOH, sodium hydroxide, in presence of potassium hydroxide. Okay, so in presence of base, suppose this OH minus or basic solution also, this dipolar ion will no longer exist as a dipolar. Okay, dipolar ion. Okay, it will convert into an anion. Okay, here you see, we know this base. Okay, now the work of this base is to abstract proton. Okay, so in presence of basic solution, this OH minus will take up a proton from this dipolar ion. Okay, so where you will get this proton? इसको proton कहाँ से मिलेगा? Here you see in this NH3 plus we have 3 hydrogens are attached with this nitrogen. Okay, so you can write it like that. Okay, NH2 bond H, हम लोग इसको ऐसे लिख सकते हैं. Okay ना, so this hydrogen is plus. Now here you see in presence of basic solution, this OH minus. Okay ना, this OH minus will take up this proton and will release as H2. Okay ना, it will be removed as H2. Okay ना, and we know, हम लोग को पता है जब ये H रिलीज होगा, this will leave this bond. Okay ना, हाइड्रोजन जब जाता है तो बॉन्ड छोड़ के जाता है. ओके ना, so after that this bond will shift to this nitrogen, so it will become NH2. NH2. So here you will get NH2. Here you will not have any positive charge, okay now, because this nitrogen will be satisfied by these bonded electrons, okay, these electrons. So here you have NH2, then CH, then bond R, then COO minus, okay. So here you see, in presence of basic solution, okay, it exists as an ion, okay. So this is an ion. So this is structure number 3, this is structure 2, this is structure 1, okay. So हम लोगों ने क्या देखा, ये जो ज़्विटर आयन, दिस इज एक्वस सॉल्यूशन, ये अमीनो एसिड एक डाइपोलर आयन में एग्जिस्ट करता है, जिसको हम क्या बोलते हैं, ज़्विटर आयन बोलते हैं. बट इन प्रेजेंस ऑफ एसिडिक सॉल्यूशन, हम जब सॉल्यूशन को एसिडिक कर देंगे ना, सो दिस डाइपोलर आयन will no longer remain as a dipolar ion, okay. So it will pick up or it will abstract a proton from this acidic solution and will convert into a cation, okay. So here you see this COO minus becomes COOH, okay. So this is cation. But in presence of basic solution, okay, so this in presence of basic solution means, we know in basic solution this base, they can release OH minus, and this OH minus will pick up this proton. The work of this OH minus or base is to abstract proton, so it will abstract a proton from this NH3 plus, and this NH3 plus will become NH2. It will become NH2, okay, and as a result, this dipolar ion will convert into an anion, okay. But here you see, now in this acidic solution, if we applied an electric field, okay, suppose if we use cathode and anode, okay now, so what will be the result, okay now, after the application of this electric field, that is after the application of this cathode and anode, okay now, this is cation, so in this acidic solution, this cation will migrate towards cathode, this cation is positive charge, and it will migrate towards a negative electrode. And negative electrode, we know cathode is negative electrode here, okay. So it will migrate towards cathode, okay. So in acidic solution, this cation, it will migrate towards cathode, okay. So this cathode is a negative electrode, so it will migrate towards cathode. And here you see, if it is a basic solution, in presence of basic solution, if we apply the electric field, okay now, so suppose cathode and anode, this is an ion, here it is a negative charge, so in the presence of an electric field, there is cathode and anode, so this anion will migrate towards anode, okay now, this anode is a positive charge electrode, okay, so it will migrate towards anode, but it has been observed that at a particular pH, there is no net migration of this dipolar ion towards this cathode or anode. This particular pH is called isoelectric point, okay. But ये देखा गया कि ऐसा एक particular pH होता है, जिस pH में after the applying this electric field, there is no net migration of this dipolar ion towards cathode or anode, okay ना. This particular pH, जिस pH में ये dipolar ion neither it migrates neither towards cathode nor anode, okay. This particular pH is called isoelectric point. समझ में आया, okay ना. Once again I am repeating here, you see, in aqueous solution, this amino acid, we know they exist as the dipolar ion. Aqueous solution में ये amino acid dipolar ion में exist करता है. और now if we make this solution as acidic solution, okay, if we add this acid in this solution, okay now, so in the acidic solution there will be a large number of protons, okay. So this dipolar ion, this will abstract a proton H plus from this acidic solution, and this COO minus will take this H plus and it will become COOH, okay. So it will exist as a cation, and in presence of basic solution, here you see, in presence of basic solution, this is in presence of OH minus, this OH minus will abstract this proton H plus from this NH3 plus, and it will convert into an anion, okay. And after that, if we use electric field, okay now, if we use cathode and anode, it has been observed that this cation, it will migrate towards cathode, there is a negative electrode, and this anion, this migrate towards anode, okay, positive electrode, okay. But at a particular pH, ऐसा देखा गया कि एक particular pH है, जिस pH में देखा गया कि ये this dipolar ion, it will not migrate towards either cathode or anode, okay. This particular pH at which this dipolar ion does not migrate towards any of the electrode, this cathode or anode, this particular pH is called isoelectric point, okay. So this is all about this isoelectric point. So you can take the screenshot from here, okay. Now the next topic that we are going to discuss is peptides and its classification. Next topic is peptide. Okay. Now what are peptides? Here you see. Next topic is peptide. Next topic is peptide. You see, these peptides are amides. These peptides are amides. Okay. Now what are amides? We know two groups are there. Okay, two functional groups are. One is amine. One is amine. Okay, NH2 bond NH2 and bond CO NH2. Okay, this bond NH2, this is called amine. This is called amine. Okay, bond CO NH2, or we can write RNH2. This is called amine, and RCO NH2. This is called amide. This is called amide. This is called amide. Okay, so here these peptides. Okay, now this peptide or this polypeptide, these are amide. These are amide. Big means in the peptide chain you will see the presence of this CONH2 group. There you will see the presence of this CONH2 group. Okay, so these peptides are nothing but amides. Okay, now how these amides are formed? Here you see these peptides are obtained by the condensation of the NH2 group of one amino acid and the CWH group of another same or different amino acid. Okay, so here if we consider the example, okay, so let us take the example of this glycine. Okay, what is the structure of glycine? We know the structure of this glycine is R bond CH2 bond NH2. Okay, now sorry, this is NH2 bond CH2 bond CWH. Okay, so this is glycine molecule, this is glycine. Okay, and the amino acid, suppose alanine. Okay, the structure of this alanine is NH2 bond CH bond CH3 bond CWH. Okay, so this is glycine and this is alanine. Okay, so here you see this is glycine and this is alanine. Okay, now so this upon condensation. Okay, now condensation. Okay, what is condensation? Condensation means after reacting two reactants, okay, there will be release of water molecules. Okay, so these peptides, they are formed due to the condensation of amine group one amino acid and the NH2 and the CWH group of another amino acid. Here you see when we condense these two molecules, one is glycine and the other is alanine. Now what will happen here? Here you see this CWH, we can write it C double bond OH. Okay, no problem. C double bond OH, and this NH2 we can write NH bond H. Okay, now so when you condense these two molecules, okay, there will be release of water molecules. Okay, as a result these two units will combine. Okay, here you see, here we have OH and here we have H. Okay, so it will, here there is a release of H2 molecule. Okay, as a result these two molecules will combine. Okay, so what we are getting here, you see we are getting NH2 bond CH2 bond C double bond O, then NH, then CH bond CH3, then CWH. Okay, here we have this CH3 molecule here. Okay, here we have CH3 and this bond, this CONH. Okay, this C double bond we can write C bond. This C double we can write like CO. Okay, and this bond is called peptide bond or peptide linkage. Okay, now this is an amide linkage, CONH. Okay, CONH, and this linkage is called peptide bond or peptide linkage. Okay, so these peptides are the condensation product of two or more amino acids. Okay, now based on the number of amino acids, on the number of amino acids, these peptides are named. Okay, this may be dipeptide, tripeptide, tetrapeptide, pentapeptide, like that. Okay, if 2 amino acids combines, then it will be called as dipeptide. 3 combines, then it will be called as tripeptide, tetrapeptide, like that. Okay, here you see, this is a dipeptide. Okay, so it can be named as glycylalanine. It can be named as glycylalanine, okay, glycylalanine, or shortcut we can write glyela, okay, glycylalanine peptide. Okay, so based on number of amino acid residues or amino acid, okay, these peptides are classified. Okay, now these peptides, when the number of these amino acids in the peptide chain is more than 100 molecules, and if its molecular mass is greater than 10,000 atomic mass unit, then it will be called as protein. Proteins. Okay, now in this peptide chain, okay, here you see, this is peptide, this linkage is called peptide. Okay, so when this large number of this peptide molecules combine, they will give rise to polypeptide. And such polypeptide in which, if there is more than 100 amino acid residues, and if the molecular mass is greater than 10,000 atomic mass unit, then it will be called as protein. Okay, so for today's class, up to this, okay, so far we have discussed about isoelectric point and peptides and polypeptides, okay, and this classification. Okay, so thank you everyone. In our next class we will discuss about nucleic acid. Okay.